Okay, this is kind of the part 3 of the parabola video. And when we're dealing with parabolas, we're going to talk about giving you kind of reverse way. Instead of giving you the equation, we're going to give you some information, some characteristics about it, and you're going to have to go backwards and write the equation and graph it. So the first thing we need to do is look at see what we're given. So in the first one, we're going to be given the fact that the focus is at 2, 0 and the directrix is at -1. So the first thing I'm always going to do is go ahead and just do a quick sketch of what we're looking at. So the first thing is the focus is at 2, 0. So 1, 2, 0. And the directrix is at, and I'll go ahead and just put this as a line, at -1. Normally they have the dotted line, but I don't have that capability right now. So we have the focus here and the directrix here. Now, halfway between, remember that the parabola is a set of all points that are equidistant to a point, the focus, and to a line, the directrix. So halfway between my point, 2, 0, and -1 is going to be my vertex. So halfway between 2, 0 and x equals -1 is going to be right here. The average of the two is going to be, I can't even write that. It's in purple. Come on, purple. Here we go. Is going to be my vertex. So my vertex is going to be at, that's probably the reason. So I wasn't drawing a, there we go. So my vertex is going to be, okay, somewhere along 0 and halfway between 2 and -1. So 2 plus -1 divided by 2 is going to give me 1/2. So 0, 1/2 is going to be my vertex right here. So, well, now we have to figure out, in order to write the equation of a parabola, I have the vertex, and I also need P. Remember, P is the distance from the vertex to either the directrix or the focus. So in this case, we could just kind of count it up. It's going to be 1/2 plus 1, or 1.5, or 3/2. If we're good with that. So now, in order to write the equation, since it is with the focus over here to the right, we're opening to the right. Remember, the general equation opening the right is, I guess I'm not going to put it towards the bottom, is x is equal to y squared. Now, basically what I'm going to do here is now plug in, I guess I kind of got to move my, let me somehow erase that. There we go. Somehow substitute in my vertex. Remember, my vertex now is 0, so I could just say x minus 0. Don't really have to put that. And now we have y minus 1/2. Remember, it's always subtraction or change the signs. So now all we need to do is put in our 4 times p, which is 3/2. So let's simplify this out. I have y minus 1/2 quantity squared is equal to, multiply the top, we get 12/2, or 6 times x minus 0, or x. So there you go. You have the equation of a parabola with a focus of 2, 0 and a directrix of -1. So now the next one we're going to do is going to be a parabola and given a vertex and the directrix. Okay, so this is a little bit different. This might be a little bit easier or a little bit harder. Let's find out. So go ahead and put in your, sketch the graph. So we're going to have a vertex now of -3, 1, 2, 3, +1. That's going to be my vertex, and a directrix of x is equal to -8. So that's going to be vertical. 1, 2, 3, 4, 5, 6, 7, 8, about here. So I'm going to go ahead and make it a vertical line, roughly. Oops, that was bad. Vertical line, about there. Okay, so now let's go ahead and figure it out. So the focus has to be, remember, on the other side of the vertex. So it's going to have to be equal distance. So if this is right here, -8, and right here is -3, halfway between is going to be, the same distance on the other side is going to be my focus. So in this case, my focus is going to be at, well, this is a total of 5 units, so I need to go 5 more units this way, so negative 3 plus 5 will end us giving us 2. So my focus is going to be here at 2, 1. It's going to be my focus. Now it's going to open up to the right since my directrix was vertical. So let's go ahead and just kind of draw my general parabola. And now we need vertex is negative 3, 1. And remember, we're opening to the right, so let's do the general format. Opening to the right is y squared, or I guess I could put everything, y minus k equals 4p times x minus h. Well, this is my h, this is my k, so when I start substituting stuff in here, I have y minus my y coordinate, which is 1 squared, equals, we'll figure out our p here in a second, x minus a negative 3, or x plus 3. So now let's just figure out our p. Well, we didn't really need to figure out our focus, because remember that this point is on the parabola, and the distance to here is just a total of 5 units. So in this case, we're going to plug in 5 for p, and we're going to get a total of 20. So there's going to be my equation for a vertex here and a directrix of here. Now we can always go through. Remember, my vertex is actually a point on the parabola. I can always check this by going in and plugging in negative 3 in for x and 1 in for y. Does that work? Well, negative 3 plus 3 is 0. 0 times anything is 0. 1 minus 1 is 0. Anything squared is 0. So, sure enough, that does give me a true value. 0 does equal 0, so that point must be on the parabola. Let's do one more. So the final one we're going to do is a parabola with a vertex of 1, negative 2, and a focus of 1, 1. Once again, let's go ahead and draw my pretty picture with a vertex at 1, negative 2, and a focus at 1, 1. So there's my focus. This is my vertex. So it must be opening up. Remember, my parabola always eats, so to speak, my focal point. Okay, my focal point is always inside my parabola. Now, I already have the vertex, which is nice, but I need to also know p. Remember, since this is a general equation of it opening up, I'm going to have, in general, x minus h squared equals 4p times y minus k. So y is equal to x squared, and we're going to have to make sure that p is positive so it opens up. So now plug in my vertex of 1, negative 2, so this is a double negative, so this becomes plus. And now let's figure out p. Well, we could just count this. From p going up, I have 1, 2, 3, so p is equal to 3. I just plug in 3 here, so my pretty nice equation is x minus 1 squared equals 4 times 3 will give me 12, y plus 2. Once again, let's just go ahead and test the only point that we know that's on the parabola, which is 1, negative 2. When I plug in 1 and negative 2, I have 0 times 12, 0, and 1 minus 1, 0 squared is 0, so 0 does equal 0, and it does check out. So that's a way we can kind of go backwards, and given either the vertex or directrix or focus directrix or vertex focus, etc., we can come up with the equation of it.